This video will talk a little bit about the history of Pluto, its discovery, but move on towards the Hubble Space Telescope observations and especially the results of the flyby of the New Horizons spacecraft in the year 2015. Pluto was discovered in 1930, and that brought the count of what were known as planets to 9. Pluto's orbit, however, is quite a bit different than the other planets. It's more elliptical, and it is more tilted compared to the plane of the orbits of the planets, other 8 planets. But let's just make progress. Better telescopes in the late 1900s enabled astronomers to find other small objects in the outer solar system in what's known as the Kuiper Belt, and about 50 of those were charted on this particular graphic. This is around the year 2000. The graphic here, you can't see the inner planets. The red band here is the asteroid belt, then Jupiter, Saturn, Uranus, and Neptune, and then the realm where Pluto resides, the Kuiper Belt. So in 2006, there was a professional meeting of astronomers, and it was adopted as a new category of objects called the Dwarf Planet that Pluto belongs to now. A dwarf planet is big enough that it's round, it has its own gravity, so many of the asteroids don't fit that category. But we have a round object that orbits the sun, not another planet, and it's not dominant in its part of the solar system. It's not gathered up, collected by collisions, the other small objects that orbit in its sort of neighborhood of the solar system. It hasn't cleared out its orbit, and Pluto is in that category. So how big is Pluto compared to Mars, compared to the Earth, compared to our moon? It's smaller than our moon. Pluto has a significant moon, Charon, significant compared to the size of Pluto. Ceres is in the asteroid belt, and there are many other in this category of the dwarf planets. Around 1990, our best ground-based observation of Pluto showed the moon Charon here. Hubble Space Telescope, with its imperfect optics in 1990, could separate Pluto and Charon. Charon was discovered in 1978 with an image not this good, but there was a little irregularity in the roundness of the image that changed periodically every 6.4 days. So we had the discovery of that moon. That was very good information for astronomers. They could then calculate the mass of Pluto, and we'll have those numbers at the end of this presentation. In 1994, Hubble's optics were improved, corrected, and we have Pluto and Charon in this image well separated. More computer processing and longer photography, or imaging, I should say, of Pluto by the Hubble Space Telescope in 2010 produced a rough map of the surface of Pluto, showing regions where there was more reflection of light and less reflection of light. There was some variation in the surface, and that's a start of being interesting. So New Horizons spacecraft, the launch in 2006, took 9 years to travel out to Pluto. It made a pass by Jupiter to gain energy in the gravitational assist trajectory. And since Pluto in 2015, it's now flown by another outer solar system object that I don't have time to go into. But the New Horizons imaging did show us more details, some details of the smaller moons of Pluto. So Charon is down here. It's the big object here. We have Styx and Nix and Kerberos and Hydra, other small objects. And if I think I'm remembering right, these were all known as dots of light before New Horizons. New Horizons did not find any new small satellites of Pluto. So here's the picture of the flyby at the closest pass, and we have Pluto well imaged, good details to view, and we'll have some more details slides coming up, but very interesting regions of smoothness fewer craters, indicating a younger surface. Pluto's surface is somewhat active. Very cold, of course, in the outer solar system, but the surface does have changes occurring to it. So let's look at some of the name features of Pluto. The Tombaugh Regio. We have the Sputnik Planeta. That's this big, almost really a glacier in the outer solar system, and other regions that you can see being named on here. I won't go into. I'm going to give you the websites to look at for some of these on your own if you are interested in doing so. But this glacier, nitrogen glacier, nitrogen ice, an indication that it is flowing, not fast at all, very slowly, but there is movement here, and there is obliteration of craters. There are craters that are filled in with some of this nitrogen ice movement over decades and centuries. A little more detailed view here, and you might want to look very carefully. There are dunes that are thought to be ice crystals, methane ice crystals, maybe a combination of methane ice crystals being deposited by wind. There is a thin atmosphere for Pluto, and it may be sublimation, some effects that are causing these features, but there are dunes on the surface of Pluto. Spectrometer in the New Horizons spacecraft could detect different molecules, and water ice was detected, these blue splotches. Most of this is nitrogen and methane, but there is some water ice available as well. So here again, the spectrometer views. Methane, very abundant. Nitrogen, very abundant. Carbon monoxide, a little bit abundant. Water ice, a little bit abundant. But mostly it's the nitrogen and methane that make up the atmosphere and the ice on the surface of Pluto. As the New Horizons spacecraft went on the side of Pluto away from the sun, sunlight was scattered by the atmosphere, and the particles of how the methane and nitrogen react and form particles in the atmosphere, those particles are thought to drift down slowly towards the surface. Sunlight scatters from those particles, and there you are, kind of a blue sky effect for Pluto. Much thinner atmosphere than the Earth, of course. This significant moon of Pluto, Charon, has interesting surface features as well. Don't have very many slides of this, but there is thought to perhaps be an indication of sort of an object-wide event that created this equatorial feature of cliffs and breakage of what you could call the crust of this object. So here are some of the data, and my table shifted around from when I made this this document, but we have the diameter, the mass, the density for these objects listed side by side. So the Earth's moon's over here. It's the largest, 3,476 roughly for a diameter, equatorial diameter, I think that is. And for Pluto, 2,376 kilometers. All these are kilometer numbers. And then Charon, very big compared to its host object. Then masses, again, the moon, 10 to the 22nd kilograms with a 7 in front of that. Pluto, roughly 1/7 of the mass, very roughly, of the moon. So a much lighter object. And then Charon, we're changing powers of 10 to the 21st instead of 20 to the 22nd. So 8 times smaller, less massive than Pluto. Density can then be calculated with the volume divided into the mass, and we get 1,854 kilograms per cubic meter. Water is 1,000 kilograms per cubic meter, so it's more dense than water. Charon, and then we have the Earth's moon. The Earth's moon is more rocky and more compact. With more mass, the gravity makes the central region of the object more pressed in. We don't have that effect occurring here for Pluto and Charon. So we have some rock here, it's thought, but much more of an icy object than our moon, and giving us then a lower density towards water and ice. We have rotation here, and Pluto and Charon are locked together in synchronous rotation. They're tidally locked. They point their hemispheres at each other, and we have 6.4 days for that time of orbit and their time of individual rotation in space on their axis. Earth's moon, 27.3 days to rotate on its axis. It's over 29 days for the phases of the moon to be completed, but that is because we're dealing with the Earth moving in respect to the sun and taking a little longer for new moon to new moon. But just the Earth's moon spinning once on its axis, 27.3 days. The atmosphere of Pluto is determined to be mostly nitrogen, some methane, and then some miscellaneous objects. And there are many more facts that I could pull out here, but if you want to investigate those, you might just put a Google search in for nasa.gov Pluto facts, and or copy down this website address. But Pluto and Charon's much smaller than the Earth's moon, less dense, more of an icy material conglomeration, but do contain some rock. Other discoveries we have here, because craters are not in abundance uniformly across the surface is somewhat active. The older craters get filled in and covered up by ice deposits as material goes into the atmosphere of Pluto and then comes back down and covers up the depressed areas. There is activity on the crust of Pluto, mountains up to 11,000 feet high, perhaps 70% rock in the composition of Pluto, and there's speculation that interior there might still be liquid water, ocean, water ice. The Sputnik Planum, as I mentioned before, largest known glacier in the solar system, and we get this blue color from scattering of particles. And the investigations of the images of Pluto's moons indicate that they probably all formed about the same time, perhaps some collision in the vicinity of Pluto, and Pluto is its gravity able to hold on to some of these small objects as a result of that collision. Then I'd recommend you go to these websites, New Horizons website, where I picked out some of these images. Again, nasa.gov and feature/New Horizons top 10 Pluto pics with hyphens in the appropriate places. Or again, do a Google search for nasa.gov Horizons top 10 Pluto pics. You probably get to that same site. Another site that I found with good information, solarsystem.nasa.gov, mission/New Horizons/in-depth. Good things to read about. And then txstate-epdc.net had some useful information for me that you might investigate as well. Then if you do find these videos useful, something like this, and you're interested in more of my YouTube videos, I have an annotated list of the videos at physics.gpclements.com for the introductory physics type videos, or first year of a physics course, high school or college, and then astronomy.gpclements.com, again, instructional videos for introductory astronomy course, high school or college. The physics course especially has lots of worked out problems, sample problems, none from textbooks, all ones that I've invented, and show you solutions and hopefully build up your problem solving skill. These websites are totally free, no registration. You do not put in your email address or anything. Use them as you wish. They're free. And if you do enjoy the YouTube videos, please subscribe to my YouTube channel. And I hope that you keep investigating our solar system, and ask your instructor, if you're in a class, ask your instructor some questions about Pluto.